All right, so we have two things left, two concepts left for triangles. The first one is similar triangles. Now, similar triangles is a pretty straightforward concept. If you have two triangles and they share their angles, then they're similar. And so basically, if I have this triangle, so if I were to slice it up into another one, then you can clearly see that the smaller triangle, let me call that ABC, and this is ADE. Then you can see that the triangle ADE is very proportional to triangle ABC, right? And I say that they're similar. Okay, so they're similar to each other. They're not exactly the same, but all their angles are the same. This one is common, of course. This one is 90 for both of them, and this one of automatically, if two angles are the same, the third one will automatically be the same for that. That's what happens here, that you have different triangles, and these triangles obviously share angles. That has an implication in the lengths. So if two triangles share an angle, share all the angles, or their values are the same, then what it implies is that their sides are proportional. Okay, so sides are proportional. Do you understand the concept of proportion? We have studied it before. Basically, when you take a fraction of these, those fractions will all be equal. So AD, this length, divided by AB will be exactly the same as AE divided by AC, and that will be exactly the same as DE divided by BC. So what I've done is I've basically made pairs of sides that are similar to each other. And then I can say that if you can have this triangle, this side, then this is proportional to this side. Or if you have this side, then this is proportional to this side. Or if you have this side, then it is proportional to this side. Now, what the examiner does is that he tries to ask you about, instead of asking you about a question about AC, they'll ask you a question about EC, which isn't really a side of a triangle. But we do know that EC is a portion of AC. So AC is nothing but E plus EC. So based on that, you can clearly see that, I know AC, so I can use AE to figure out what EC is. Okay, so they ask you to do that. So just know that if angles are all the same, triangles are similar, and if they're similar, then their sides are proportional. Okay, so let's show an example of this. In a triangle above, DE is parallel to AC. So we can see that DE is parallel to AC, and AD is 2, DB is 3, DE is 6. Okay, what is the length of AC? So what they've basically asked us is to figure out, first of all, they've told us they're parallel. And if it is parallel, that means this angle is same as this, and this angle is same as this, and not this angle is shared. So automatically these are similar. BDE, that triangle, is similar to BAC. Okay. Now let me make ratios of the sides. This is the side I want to figure out. I want to know AC, the first part. I want to know AC. So that is X. Now what I'll do is that I'll make pairs of sides. Okay. So this side over here is proportional to this side. So I'll say that X over 6. Are you seeing it? Do you see this red line going around?
Circle, but like, sir, you were explaining it and I didn't see the explanation.
Okay. So now it should work out. So this side, AC, is proportional to this side, DE. Similarly, this whole side is proportional to this small side. So what I'm going to do, what is the length of this whole side AB? That is 5, right? And this side DB, the smaller one over here, that is 3. So there you have it. That's my proportion.
5 over 3 would be a proportion, sir. Okay.
Yeah. So now I can say that X is going to be, I multiply this side by 6. So X is going to be 10. So there you go. X is 10.
But I asked you about the area, no? The ratio, sorry.
No. In the first part, they asked us about the length. In the second part, they're asking us about not the area, but the ratio of areas. AC is 10, yes. Now here's the thing. This, if you divide any two sides of a similar shape, and it doesn't just apply for triangles, any shape that is proportional to the other one, which means their angles are all the same, then if you divide any two sides, you get K. This is called scale factor. So for example, over here, K would be 10 over 6 or 5 over 3. Okay, all I'm doing is I'm dividing the side of the larger triangle by the side of the smaller triangle. Now that's K. And we say that K is ratio of their lengths, K squared is ratio of their areas, and K cubed is ratio of their volumes. For all similar shapes, the ratio of lengths is K. It's a scale factor, like basically how much bigger is the other one compared to the smaller one. The ratio of their areas is square of that. The ratio of their volume is cube of that.
Sir,
Yeah.
there weren't the formulas for all of these lengths, areas, and volumes different in O levels?
No, they were the same, but in O levels, instead of calling it scale factor, what they did was they just plugged in the value. So instead of saying K, they said L1 over L2 squared is A1 over A2. And L1 over L2 cubed is V1 over V2. It was the same thing, just disguised as something else. And it's up to you. Whatever you're more comfortable with, it will work. So let's see over here. I have a 6 over 10 as my ratio, right? So 6 over 10 is my ratio. And I want to figure out, this is my K. This is the ratio of their lengths.
Yeah, 6 over 10, because you're trying to find a ratio. That makes sense, sir.
Yeah, that's my scale factor. And now if I square this, I get my...
Like, I didn't hear much of what you said.
Oh, I'll repeat then. So K is basically the ratio of sides.
Okay.
And square of that is ratio of areas, and cube of that is ratio of volume. That's a geometrical fact. We don't need to go into the detail of that. So basically, whenever you have two shapes that are similar to each other, which means similar shapes are the ones that have two things. All angles are same. And secondly, their sides are proportional. So if these two things are there for any two shapes, they're similar to each other. For example, your hands from 2 years ago and right now, they're similar to each other. They might not be exactly the same size, but the ratio in which they grew up are exactly the same. So that's kind of how this works. So you have similar shapes. For example, if I have a scale model of a car, let's suppose I have a scale model of Model 3. And then I go to Tesla's showroom and they have this Model 3 actually there, then it will just be a bigger version of that thing. But everything else will be identical, similar, proportional, right?
Yeah.
Yeah. So that's what similar shapes are. And for similar shapes, we have a scale factor, which is basically saying that how much bigger or how much smaller is something compared to the other one. So that's called K, or ratio of any two lengths that are proportional. And square of that is this ratio of area, and cube of that is ratio of volume. Yeah, so that's what we're doing here. Here they asked us that what is the ratio of area of BDE to area of BAC. They did not ask us about the value of area. They asked us about ratio of area. And for that, I know that ratio of area is basically K squared. K is 6 over 10 squared. I'll simplify this. 2 3s are 6, 2 5s are 10. So it comes out to be 9 over 25.
All right, so I think I made a bit sense of that.
Okay, great. Now that was similar shapes. And that's all you need to know about them.
ये जो 6 over 10 है, उसको आपने whole square क्यों नहीं किया? मतलब आपने उसका square क्यों नहीं पहले
किया मैंने उसको. I first simplified it 3 over 5 and then I squared it.
It's the same thing.
Yeah, it's the same thing. All right, so we have radian measure now. Radian is basically at the heart of it, it's just another unit to measure angle. Okay, just like dollars are just another currency to measure money, right? So radian, which we summarize as rad, that is basically a unit of angle. Just like we have different units like kgs and pounds. They are two things measuring the same thing, like roughly the same thing, and but they have different values and you can compare them. Just like that, you have radians and degrees. Now, how do they relate? So for example, if you were talking about in money terms, I can say that what's the dollar rate today? 178, let's say. So 176 rupees is $1, right? So that's my conversion factor. So if I wanted to figure out, all right, how much is 1,000 rupees in dollars? So you'll be like X and cross multiply. So 176X is equal to $1,000 and X is going to be 1,000 over 176. And that's how you know how many dollars is 1,000 rupees, right? Just like that, you have a similar factor for radians. Pi, you know what's pi has a value 3.142, and yeah. So that many radians is equal to 180 degrees. Have you used radians before?
Yes, sir.
You have, all right. Moise?
सर उसकी मुझे conversion आती है थोड़ी बहुत use कभी नहीं किया.
But that's all you need. You just need the conversion. You just need to know that there's pi radians equal to 180 degrees. कहाँ से आता है radian? क्यों use करते हैं? We don't need to get into that. It's just another number, another way of measuring angles. Okay, so let's say I want to know how much is 45 degrees in radians. So it will be 45 is x. So 45 pi is equal to 180 x, and x is going to be 45 pi over 180, right? Similarly, if I told you that, all right, how much is 1.5 radians? So you'll be like, okay, pi radian is 180 degrees. So 1.5 radian is x. And cross multiply, and you'll know pi times x is equal to 180 times 1.5. And divide that by pi, and you have your degrees. Okay, that's it. Just use the ratio method to convert it. That's all you need. Now, one more concept over here. If you have a triangle, then if you have this angle, then you know tan theta. Ahmed, do you know this? Tan theta?
Sorry, I'm in calculus.
Oh, you have. Okay. So tan theta is basically the height of the triangle divided by the base of the triangle. And we can also call it opposite over adjacent, or we can also call it perpendicular over base. Now, another way of looking at that is that imagine if this line, this triangle was actually on the graph, and this wasn't really a hypotenuse, it was just another line going like that. Then tan theta is nothing but gradient or slope of the line. Okay, so we know slope. So slope of a straight line is equal to tan of its angle, the angle it makes with the horizontal. So for example, if you have this question over here, and this question is saying that in the xy plane above, line M passes through the region, has a slope of square root of 3. All right, so its slope is square root 3. If a point A lies on line M and point B lies on x-axis, show that what is the measure of angle AOB? Again, this angle AOB is, let's call it theta. Then tan of this theta, okay, tan of this theta is equal to slope. And that means tan theta equals to square root 3. Okay. So how do you find the angle? You just take tan inverse of this. Now this is a calculator question, so you will need to use your calculator for this. So if you have your calculators, take them out. First, convert them to radian mode.
Radians, right, sir?
Yeah, radians.
And you want to tan inverse?
Tan inverse of that, yeah.
So it's pi over 3.
Pi over 3, okay. So you know how to convert it to radian, right? That's radian. Okay, that's radian mode, that's fine. Moise, what's your calculator? Can you also show if you know how to convert it to radians?
No, I don't.
Okay,
this is my
show me your calculator. All right. First of all, buy another calculator, okay? Yeah.
Okay.
Because this one is pretty old, and this one will put you at a disadvantage when you go to SATs. Just borrow it from somebody else if you don't want to buy it. And even in this one, if you go to mode, like next to on button, there's the button for mode.
Yeah.
And if you keep on pressing it, you will see one that says dig, rad, and something else.
I see comp, SD, reg. Okay, I see deg, rad, gra.
And grad.
Yeah. So check the one that is for radian. So is that
Okay.
number 2?
Yes, I pressed it.
Yeah, now you're in radian mode. If you want to convert back, do the same thing for deg, which is degree.
So अब ये हो गया, अब क्या करना है?
अभी ये radian हो गया. Okay.
तो बस
So
ये
whatever
दिखा-
you do, you'll get your answers in radians now.
Okay.
So take tan inverse of square root 3 and you'll get a value.
Tan inverse of 1.04.
Yeah, so that is pi by 3. But again, because you don't have this calculator doesn't show fractions, how will you figure it out on the SAT? It will waste some time. Of course, you can figure it out by dividing pi by 6, then pi by 5, but why waste that time?
Yeah.
Okay, so just understand the concept that slope is equal to tan theta of any straight line. And we are done with triangles. Do you want to go over the questions now, or should we move on to the next chapter?
So is it possible if we could have like a short revision of geometry as a whole?
We have just started with geometry. I can review that. Moise, if you need revision, that's all right. But otherwise, just start working on the geometry problems for triangles.
Okay, sir.
You'll see that in that file, there's a chapter for triangles.
So sir, could we revise what we've learned so far for geometry?
Yeah, sure. Have you watched the video?
The recording of class?
Yeah.
No, sir. I think I was present in classes for all of them. I didn't really need to.
You were present in the class?
Yeah, I think so. I don't think I
Okay,
missed. I think I only missed one because I was sick or something.
Yeah, I remember that one. Okay, so basically, we have studied a few basic topics in triangles, basically. Moise, please use this time to attempt questions on triangles. Okay.
Ji, sir.
So the first thing that we talked about was that the triangles have this theorem that any two sides, if you add them up, their sum is greater than the third side. That's the first idea that we came up with. Okay, it was here somewhere. Yeah. So we said that obviously all angles on a point are 360. Okay. So if you pick a point, then all angles around it, that's 360 degrees.
Okay.
And it comes from Babylonians who said that if you have a stick and you have sun and it has this shadow, then every day the shadow shifts a little bit. And whatever it shifts with every day, that is a degree. All right. In fact, the word degree comes from day gradient. You know, gradient is change. So day gradient, like the change every day.
That's actually quite interesting.
Now, those degrees on any point that is 360 degrees. But if you draw a straight line, then that angle would be obviously 180. Now, angles on a line are 180, we know that. And there are three shapes that will help us figure out pairs of angles. So I know that you know this, you were answering these questions. So F is for corresponding angles, vertically opposite angles, we can see them by X. And then we have alternate angles, which is basically a Z. So every time you identify this shape being made, like FZ or X, you know what angle pair we are talking about. All right. So they're all pairs of angles that we have. I'm sorry?
Which one will be corresponding then?
Corresponding are the ones F, the ones that make F.
Yeah, but like in that example that you've drawn to the right, which ones are corresponding? A and A.
A and A, yeah. Because they make an inverted F.
Okay, I see.
Yeah. You see this one?
Sir, आपसे एक सवाल है.
पूछो.
Sir, it's not related to any of this. Sir, a fees due है ना?
Yeah.
So, sir, how much do I have to pay? Because someone from Advise, I don't know who, sent me a message saying that I have to pay 8,000.
Same, sir.
No. 8,000 is the fee for O levels. This is sad. This is 18,000.
Yeah, the message I got said 8,000. I was also confused about that. I was about to pay 8, but I was like, Let's think.
No,
Yes.
it's 18. They must have missed that one.
सर मैं जो आपने सर अकाउंट भेजे उसमें भेज दूं मैं?
Yeah, there is only one account that I use for this.
ओके सैयद अहमद वाला.
Yeah.
और सर 18,000 2 महीने के लिए नहीं था?
And Z. So for example, if you can identify a pair of alternate angles, can you do that?
Alternate in this case would be what? B and D.
B and D. I don't think so. Because, oh yeah, B and D, like this.
The
Okay.
inside B and D.
The other pair, that's an X. That's over here, they're vertically opposite.
So
But
again,
this time,
only lines. I don't see anything. I don't see you doing anything.
यार क्या मसला है आज इसको? Do you see it now? Do you see that Z?
Yeah.
I have no idea what's
That's what I
happening.
was talking about. It's the inside B and D, not the outside ones.
Yeah. Okay. And these are pairs of vertically opposite angles. Yes.
Yeah. Okay.
And then these are called interior angles, and they are supplementary. Basically, that they add up to 180. Okay. So yeah, we have that, and yeah, that was the main idea of different angles on a straight line. Then we have polygons. Polygons are closed shapes. They're very difficult to define, like what exactly is a polygon and what isn't. And there isn't a final definition. Mathematicians are split on this, but we'll just take any closed shape as polygon. And any polygon, obviously, you can split its angles into interior angles and exterior angles. And how do you make a polygon? You just draw straight lines, and there you go. I've drawn a triangle. That's inside thing. So every line that you draw has an angle of 180, right? This is 180, this is 180. And I can divide that into the interior angle and the exterior angle. Now, here's the thing. Any polygon, no matter how many sides, sum of exterior angles is 360.
Okay.
Okay? Any polygon, doesn't matter whether it's 5-sided or 500-sided. Sum of exterior angle is 360, which means if I add this one, and this one, that's 360.
Okay.
But if I add all of these, that's 180 times 3, because every angle is 180 degrees. Which means I have a pretty straightforward relation between the angles on the inside, the interior angles, and the exterior angles. Exterior is always 360, and the total is always 180 times n. N is number of sides. So that gives me the sum of all interior angles is 180 times n, which is the total angle minus the exterior angles.
Okay.
Okay, so that's 180 times n. Usually what people do is that instead of memorizing it like this, they would just take 180 as common and say it's 180 n minus 2. And that's also fine. It's the same thing.
I don't get that.
So basically they took 180 as common.
Yeah. Oh, okay. Oh yeah, I get it now.
Yeah. So all the interior angles, if you sum them up, it is 180 times n minus 2. So for example, over here, a plus b plus c, that is 180. Why? Because 3 sides, so 180 times 3 is 540 minus exterior angle is 360, that's 180.
So the
If I
interior
do the,
always equal 180.
I'm sorry?
The interior angles always equal to 180.
For a triangle, yes.
Okay.
Yeah. For a square, it will be different. It will be 180 times 4 because it has 4 sides minus 360. So for a square or any quadrilateral, any shape with 4 sides, it is 360.
What about like a pentagon then?
Pentagon, just plug this in. 180 times 5 minus 360.
Okay, so what?
540, I think.
Yeah, 540.
Yeah. So you add all of them up and you get 540. Doesn't matter what kind of pentagon you have. But you can have a regular shape. Regular shape is one in which all angles are equal. Which means all you're doing is you're dividing all the sum equally. So if the sum is 180 for a triangle, in a regular triangle, which is equilateral, one angle will be 180 over 3, that is 60. In a regular quadrilateral, it will be 360, the interior, divided by 4, which is 90. That's square. In a regular pentagon, it will be 540 divided by 5, which is 108.
Okay.
Okay, so all you're doing is you're dividing it by number of sides. The interior angles divided by number of sides, or the exterior angles divided by number of sides.
Okay.
That's a regular shape. So then we did a few examples of this. And this, all right, so any questions on interior angles? All right, let me give you a question.
Okay, sure, give me a question.
So I have this, oh God.
A hexagon.
I have a hexagon, and it's a regular hexagon. So
Okay.
what is this angle?
This would be 6 sides, right?
It is 6 sides, yes. Very good. So it is 120.
Yeah. I was allowed to use a calculator there, right?
I'm sorry?
I was allowed to use a calculator there, right?
Yeah. So for example, now we have a few theorems that are specific to triangles. For example, this is one theorem that says the exterior angle, this angle x, is equal to sum of the two other interior angles. So x is a plus b.
How is that possible, sir?
Oh, it's pretty straightforward. So I'll show you how that is. The sum of these two angles is 180.
Yeah.
And sum of this one, and this one is also 180.
Oh, yeah. Okay.
So put them equal to each other and c cancels out and you have a plus b equal to x. In fact, it is also applicable on quadrilaterals. For example, this quadrilateral, this angle is the sum of this one, and this one.
Yeah.
Because the total should be 360 and this one plus this one is also 360. For example, if I have this quadrilateral, then I pick this angle, it will be the sum of this one, and this one. And we did a few examples of that. This was another question on that. Same thing. Yeah. We talked about how we can draw different angles. And I tried to explain how this comes out to be, but because we didn't have compass and all that, it was difficult to show that. So then I straight away jumped to this theorem that pick any two sides of a triangle, they should be greater than the third side. Yeah.
Because they all equal 180, eh? Yeah.
And then we talked about different kinds of triangles, isosceles, equilateral, and I think then we went to Pythagoras theorem, right angles. So you know Pythagoras, a square plus b square is equal to c squared, right? And then we had these three pairs, which are usually asked about, these four pairs that you need to memorize. And they're basically Pythagorean triples, basically dimensions of a right triangle that are used multiple times in SAT. So 3, 4, 5 or any of their multiple, 5, 12, 13, 8, 15, 17, 7, 24, 25, or their multiples. And you can just, if you remember this, you can simply apply that right away.
Sorry, all the multiples of any of these 12 numbers.
Yep. So for example, if I said, this is a right triangle, and this is 50 and this is 48, what is this side? So either you apply Pythagoras theorem on this, or you can just say that, wait a minute, isn't this the
Would it be 14?
double of this? So it will be 14. Yeah.
Okay, so like they have to correlate. They can't be any three random. They have to be one of these pairs.
Yeah, they have to be one of these triples.
Okay.
And then we talk about two special right triangles, the isosceles one.
Yeah, 45, 45. Okay.
Yeah. And 30, 60, 90. That's where we ended the class.